Dilek and greetings to all my dear students, and welcome back to yet another video lesson. Well, as of today, I'll be starting with a new chapter. The name of the new chapter is Data Handling. Having understood or having learned the recently concluded chapter of the Python fundamentals, you should be pretty much confident with the basics of Python as a programming language. We have not only learned the basics, but we also have managed to learn some basic programs written using the Python programming language. Well, in this particular chapter, we'll be learning the detailed aspect of the data type and the operators. Yes, we did cover a bit of the topics like the data type and the operators in the recently concluded chapter of Python fundamentals. But in this chapter, I would like to go a little deeper and a little further. So without further ado, let's get started. First things first, let us try to understand a little more on data type. What is data type? In the real life application, we need to deal with various kinds of data. For example, let's talk about your admission number. In order to store your admission number, the data type needs to be in the form of integer. Let's talk about the percentage of your annual examination. It better be in the form of float. Okay? And then, let's say you would like to store the case history. In the database, the data type has to be string. And then likewise, there are many more kinds of data. So the programming languages, they should offer some kind of facility in order to handle such kind of data. For this reason, the programming languages, they offer the data type. So the data type not only determines the kind of data, but it also identifies the kind of operation which are allowed on these data. Now, when I say this particular data is a string, if the programming language determines this particular data to be of string data type, which means you cannot perform mathematical calculation, right? So it not only determines the type of data, but it also identifies the kind of operations which are allowed on these data. Okay, so we have learned few data types in the earlier chapter. Okay, so the things that I'm going to discuss or explain now are totally the same. It's just that I'm going a little further. The first data type is integer, if you could recall correctly. In the integer, there could be like two types. The first one is signed, and then the second one is bool. The signed means you're referring to the usage of sign. So for the negative numbers, we have this minus sign. For the positive numbers, we have the plus sign. So the signed integer means we are referring to the normal integer values that we have been using till date. A bool, as you know, there are two boolean values. The first one is true and the second one is false. Why bool is treated as a subcategory of integer is bool value of true is internally represented as 1. Bool value of false is internally represented as 0. But for the sake of our understanding, the programming languages have interpreted the values of 0 and 1 as false and true respectively. Alright, let's say if I write something like this, bool of 1, then I get this, the value of true. So it means this particular function of bool will convert the integer value to true. It's just a mean to explain that 1 indicates the true value, right? And then you have bool. If I write here 0, I get the boolean value of false. Okay, so I think there should not be any harm if I just write this. If I write 2 here, I get the answer as true. So in order to simplify the matter, 0 is represented as false and all the non-zero values. 1 is a non-zero value, 2 is a non-zero values, right? So it's important that you know this. 0 is represented as false and all the non-zeros are represented as false. But normally, we directly associate 1 to true for this simplicity of understanding. Alright, so you have two subcategories. The first one is signed, and then you have the bool. And then the next up is you have the float. Float means you're referring to the real numbers, numbers having the fractional part. So again, like I said, there are many situations where we have to use the float data type. Alright, there are two ways to assign float values. The first one is pretty simple. We do the normal way. This is how you assign the float values. Alright, just in case if you have a large numbers with many zeros, with multiple zeros, you could simplify the representation using the exponent notation, which I believe you must have learned in your junior classes. Let's say I would like to have 10,000, right? So instead of writing 4 zeros, you can use the exponent notation like this. Okay, so this E is the exponent, right? So when you try to print the value of B, you will get the answer as 10,000, right? So these are the two ways via which you can assign the float values to a float variable, right? Now let's compare the float with integer. Float holds few advantages over the integer data type. The first one is pretty simple. If you want to if you want to express some values in between the integer values, let's say I want to print or I want to use some numbers between 3 and 4. If you use integer, you cannot do it, right? So that's when you have to use the float. So the first advantage, which is pretty simple, with the float you'll be able to express numbers in between the integer values. Now the second advantage is the float supports greater range of numbers. I won't explain everything right now. It'll sound a little complicated. I'll just tell you what do you mean by this in a very brief manner. Let's say if the integer supports numbers from positive 10 to negative 10. This is just an example, right? So if you use the integer data type, you'll be able to use the numbers from positive 10 to negative 10. You cannot use negative 11 or positive 11, right? What happens with float is, when I say float supports greater range of numbers, means float could support numbers starting from positive 50 to negative 50, right? So you see two examples of ranges here. The first one for the integer is positive 10 to negative 10. However, you have the float representing numbers from positive 50 to negative 50, right? So if you want to use the numbers beyond the range of positive 10 and negative 10, you have to use the float, okay? Since this is not the complete picture, you will find gaps and holes in it, but just hang on, right? Just understand what is it, when I say, the greater range of numbers. I'll come to that little later. So that's the second advantage. So when you want to express huge numbers, the float will be able to support, however, the integer will fail to support, alright? However, one disadvantage of float over integer is, whenever you use the float data type, the operation will be a little slower. It's understandable. For the machine will take little more time to process the float values than the integer. Because look at the very structure of the data type. The float has two parts. One part before the decimal point and then another part after the decimal point. So which means the machine has to deal little more with the float data type. Hence, the computer operation will be a little slower with float than the integer, right? So these are the three comparisons between the two. The first one is float will be able to support the numbers in between the integers. The float supports greater range of numbers. However, having said that, the float is float data type operates slower than the integer. Okay. Now the next data type is the string. We have this general name called sequence. I'll come to that a little later. So we have string. The next data type is string. String, as you have learned quite a bit in the earlier chapter of Python fundamentals, string is a random collection of characters, or it could be sequential collection of characters which are enclosed in a pair of single quotes or double quotes. So the string is generally used to refer to a textual data. Okay, so now let's say I have a string value like this. Let's say I have here Tibet, right? So the data type, if you just check print the type of A, you will get the str, right? You are familiar with this. The string data type, these characters are Unicode characters. Okay, Unicode stands for Universal Code. Okay, Unicode. So the individual characters are Unicode. Now, when I say Unicode, what do you mean by Unicode? Unicode is a character encoding system in which the characters of all the languages are encoded in the Python programming language. Not just Python programming language, many other programming language. The characters, that we see of a certain language, be it Tibetan, be it English, when these characters need to be interpreted in the computers, they need to be converted to a number. The reason is, ultimately, the machine understands nothing but numbers. Ultimately, all the data needs to be converted into 0 and 1. Let's say the Tibetan character ka, that we write, has to be converted into some kind of number. Okay, let's say 101. I'm just giving you an example, right? So this 101 is easy to break further into the combination of zeros and ones. And zeros and ones are the ultimate numbers which computer understands. Okay, so you have the character representation in the form of number. So this character encoding system, could be either Unicode or ASCII. It could be Unicode or ASCII, right? So ASCII is a character encoding system which is used to represent only the English language based characters. Okay, I repeat, ASCII code, ASCII, right? American System Code for Information Interchange, right? So this is a character encoding system which is used to represent the characters of the English language. It has like 1 byte. So when you say 1 byte means a byte has 8 characters, right? So 8 bits, 8 bits. 1 byte is equal to 8 bits, right? So it'll be able to accommodate only the English language based characters. However, the question is, what about the rest of the characters of the languages all over the world? So that's when Unicode comes into the picture. So Unicode is a character encoding system which will be able to represent the characters of all the languages. So you should know this. What is Unicode? It's a character encoding system. What is ASCII code? ASCII code is again a character encoding system representing the characters in the form of numbers. Alright? So in the string, all the characters are Unicode. Okay? Now the question is, how do I refer to the individual characters? Okay? How do I refer to the individual characters? These individual characters, you can see here Tibet, right? They have an index values. There are two kinds of indexing the forward indexing and then you have the backward indexing. Alright? Forward indexing always starts from 0, 1, 2, 3, 4. Okay, I hope you're able to see this. So the first character will have the index of 0, the second character will have the index of 1, so on and so forth. Okay, so now when you want to refer to the first character, so you could perhaps do it like this: A, okay, you have to use the square bracket, and then when I write 0 here, and then when I press, I get to see the letter T. So which means you're referring to the 0th index of the A string. So A of 0 means you're referring to T. A of 1 means you're referring to I, right? So this is how the forward indexing works. Now when you want to check out the last one, then it'll be like 0, 1, 2, 3, 4. So this will be A of 4. So when you press enter, you will get the last T. Okay? So this is how the indexing in string works. But there could be a backward indexing also. Okay? So it could be like, let's say we'll come up with another string variable, say Python. Okay, I press enter. Now when I say A of minus 1, I'm referring to the last character. So if you use the negative indexes or indices, the indexing will take place from the right hand side to the left hand side, or in other words you could say the backward. So when you press enter, it has to be B minus 1, right? Oops. Okay, you have B minus 1, right? So when you press enter, you will get the last character. And then minus 2. B minus 2 means you will get the second last character. This will go on and on, right? Now if I just sum up into something like this. Now let's say if I want to refer to the last characters, the last character will always be the length, the total number of characters minus 1. What will be the index of the last character of the string if we try to generalize? Let's say there is a big string value, a paragraph. Okay, you would like to retrieve, or you would like to know the index of the last character. If you just go on counting, it will take days. So there should be a way to generalize, to access the last character or the first character, right? So if you could take a closer look, Python has how many characters? The counting number always starts from 1. Remember, so it has to be 1, 2, 3, 4, 5, 6. However, the index always starts from 0, 1, 2, 3, 4, 5, right? So the index number is always 1 less than the counting number. So if the counting number starts at 1, for P, the index value is 0. Okay? So what is the length of Python as a string? You have how many characters? You have 6 characters. 1, 2, 3, 4, 5, 6. However, the index of the last character has to be 0, 1, 2, 3, 4, 5. So do you see a situation here? The index number is always 1 less than the counting number, right? So you could always refer to the last character as, just take a look at this. If I just write length of B, what do I get? I get the answer as 6. So this is a function which returns the number of characters in the string, number of characters or the length of the string. And then please remember this particular function will return the number of characters. And whenever you count the number of characters, it has to start from 1. Okay? I hope I made myself clear. So perhaps you could do it like this. B of, okay, length of B minus 1. Okay? Just look at this. The length of B is how much? The length of B is 6. Okay? 6 minus 1 is 5. So when you say B of 5, you are referring to 0, 1, 2, 3, 4, 5. So when you press enter, you will get to see the last character. So the question is, how do you refer to the last character of the string? It has to be the name of the string, and then you have the square bracket, the length of the b minus 1. Okay, now let's say we'll come back. Let's say we'll have this Python again. Okay, now we'll try to use the backward indexing. So when I say b of minus 1, it refers always to the last character. Okay, when I say b of minus 1, it always refers to the last character. Okay, so it has to move backwards. All right, now the numbers move like minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, so 6 is the actual length of the string. 6 is the actual length of string. So how do I refer to the last one? It's simple, right? b minus 1. Okay, b minus 1. All right, I get the last one. Now if I want to refer to the first character using the backward indexing, please notice, using the backward indexing, then perhaps I could do something like this. I can use the negative sign and then the length of the b, right? So when you press enter, you will get the first character. Look at this. Now the backward indexing, starts like minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Unlike the forward indexing where the number starts from 0, but the backward indexing starts from 1. So the first character's index will always be the negative of length of b. Just give it a little thought, it should be very simple. So this is how you actually refer to the string data type. I hope you are clear with this. Now the reason why we need to access the individual characters of the string is, I'll just give you a very simple example. Say in Microsoft Word, there is a feature of changing the cases. Be it changing the case of the entire paragraph into the uppercase, the lowercase, or capitalizing each word, changing just the first letter of the paragraph or the sentences or the word for which we'll have to refer to the individual characters. That's when these the features of string comes with the picture, right? So I hope you're clear with this. Now the next data type, you have like the list, and then you have the tuple, okay, and then finally you have the dictionary, right? So list, tuple, dictionary, we have, in fact, for the string, list, tuple, and the dictionary, we have full chapters. But as of now, I'll just explain briefly. Now this list is a data type. I'll just tell you what it is, and that should be more than enough. List is a comma separated values which are enclosed in a pair of a square bracket. Okay, list is a data which has comma separate values which are enclosed in a pair of square brackets. I'll just give you an example. A is equal to, let's say if I write something like this. Okay, so what do you see here? You have comma separated values which are enclosed in a pair of square brackets. And then how do you know this is a list data? Remember, we'll have to take the help of the type function. Okay, so when I say type of A, I'll get the data type of list. So all you should know as of now is the list is a comma separated values which are enclosed in a pair of square bracket, but the individual, the data type could be similar or it could be different. Let's say if I can have something like this, okay, say, and then like this, right? So when I check, the type of B, I'll still get the answer as list. So this time, I have a list of B in which the elements belong to different kinds of data. The first one is the integer literal, The second one is the string literal, and then third one is the Boolean literal, right? So this, is how this looks like, right? And then we'll quickly move on to tuple. This much of explanation is more than enough as of now, okay? But in times to come, we'll be dealing with one whole chapter dedicated each for the string, list, tuple, and the dictionary, all right? So the tuple, the tuple is again a comma separated values, but this time they are enclosed in a pair of the common bracket or the round braces, right? So perhaps, this could be one example. And then when I say type of C, I'll get the answer as tuple, right? So again, you can have different kinds of data. So this is the tuple. You may feel, a little funny, what could be the difference between the two, but have patience, right? So the next up is you have the dictionary, right? So the dictionary in real sense, you have the Oxford Dictionary. What do you have in dictionary? You have a pair of the word and the meaning, right? So likewise, dictionary is a wonderful feature which is a new stuff in the Python programming language as compared to the earlier languages, right? So in this particular data type, you will have a pair of key and values, just like you have the pair of word and meaning in the Oxford Dictionary. Likewise, in our dictionary, you have again a pair, but this pair will comprise of the key and a value. So it could be something like D is equal to, let's say 1. Okay, I'm just giving you a simple example. 2, and then you have the B, right? Okay, so each element is nothing but a pair, but the pair will have a key as well as a value, just like the word and the meaning in the English dictionary. So when I press enter and type, check the type of D, you will get the data type of date or dictionary. Okay, so these are the built-in or the core data types of the Python programming language, right? So if you are asked this question in the examination, write all the built-in or the core data types of the Python programming language. It has to be integer, you have the float, string, list, tuple, and then you have the dictionary, right? Now let's move on to the next topic. I was just talking about the range of numbers, which is supported by the integer as well as the float. I just told you that float supports a greater range of numbers. In Python programming language, now there is a big advantage when it comes to taking care of the range of numbers which are supported by the different kinds of data types. But in order to know why this is an advantage, you should know, why it was or why it is a disadvantage. Something similar to the example of unless and until you know what unhappiness is, you will never understand what happiness is. Okay? I hope you're getting me. So unless and until you know the meaning of unhappiness, you will never understand what happiness is. Okay? So we'll shift away a little bit from Python and then try to understand the crux of the matter, and then you'll be able to understand why this is such a big advantage in the Python programming language. Now let's say in Java programming language, which is again one of a very popular language in computer science, there is a data type called byte. Okay, there is a data type called byte. Just there. This is a data type, and then you have several data types like the short, the int, the long. 4 of them for just integers. However, in Python programming language, we just have only one, even though bool is treated as subcategory of integer, but technically we just have only one data type for integers. But The languages like C++ and the Java, it's important to know these basics. In the earlier languages, there are several data types just for the integer. For example, it could be like the char, the short, the int, the long. There are 4 of them just for the integers in C++. Same is the case with the other programming languages like Java. Now let's try to understand what range is. This is one integer data type in a language of Java, alright? Okay, so for each the data type, there will be a size allocated. So for byte, it's something similar to this. If you are a 7th grader, you'll be allowed this much of room. If you are an 8th grader, you'll be allowed a bigger room, slightly bigger room. Okay, and then if you are a 9th grader, again a bigger room. So based on the necessity, the students are allowed to use the room. For the 7th grader, you don't need such a big room. I don't know, the example sounds a little stupid, but just trying to get at the individual data type having a different size. Okay, so for the byte, the storage capacity is one byte. Okay, this marker isn't working well. So 1 byte means 8 bits. Alright, so in order to store the number in the form of a data type called byte, the storage size allotted is just 1 byte. Okay, this is the name of the data type, and this is the actual size, okay, which is allocated to the byte data type. So 1 byte means, don't be confused, this is the name of the data type and this is the size. 1 byte means 8 bits. Remember, so 8 bits means how many numbers can be accommodated in the 8 bits. How many numbers can be accommodated in the 8 bits? The question is, now let's say I have just one box. Okay, I have just one box. Now let's say this is 1 bit. Okay, 1 bit means either it could be, bit stands for binary digit. Now when I say there is just 1 bit, the question is how many numbers can you represent in this? Okay, so either it can be 0 or it can be 1. Computer understands only binary digits, 2 digits, and those 2 are 0 and 1. So if you have 1 bit, the total numbers that you can represent is just 2. Either it has to be 0 or it has to be 1, right? So either it has to be 0 or it has to be 1. So with 1 bit, you can represent how many different kinds of numbers? Only 2. What are those 2 numbers? Either 0 or it has to be 1. Okay, so likewise, let's say we'll have 2 bits. Okay, we have 2 bits, which means 2 boxes, right? So which means I can have the combination like this. Either it could be 0 0 or it could be 0 1 or 1 0 or 1 1. That's it. Using 2 boxes, using 2 digits of 0 and 1, the question is how many numbers can I represent? Just 4, right? Either it has to be 0 0, 0 0 or 0 1 or 1 0 or 1 1. Do you see any other possible combination? You cannot, right? So this time you can represent 4. So likewise, if you just go on, say 3 bits, okay, using 3 boxes, you'll be able to represent, starting from 0 0 0 to 1 1 1. In between, there should be like 6 combinations. So you will have 8. So when you go on with this relationship, you could come up with a formula. The formula perhaps could be 2 raised to n. Okay, so 2 is the base. What does this 2 represent is either it has to be 0 or it has to be 1. That will remain the constant, right? However, this n represents the number of bits or the number of boxes, right? Just take a look at this. What is the value of n over here? It's 1. So 2 raised to 1 is 2. What is the value of bits? It's 2. So 2 raised to 2 is 4. The number of bits is 3 here. So 2 raised to 3 is 8. So likewise, if a byte data type has the storage capacity of 1 byte or 8 bits, the question is, how many possible combination of numbers can it represent? So using the formula of 2 raised to 8, this will be like 256. Okay, so when I say 2 raised to 8 is equal to 256, which means the total number of the values that could be represented using a byte data type is 256. But this should be equally divided into 2 halves. One half for the negative numbers and another half for the positive numbers. So this will be like, now I won't go in depth, alright? So if you just break this into 2 halves, it will be like minus 128 to positive 127. And then in between you have the 0, alright? So 127 positive numbers, okay? And then you have 0. So 128 numbers on this side, and then again another 128 numbers on the left hand side. So if you add up these two, you will have the total possible numbers of 256. So using a byte data type, you'll be able to support numbers between the range of minus 128 to positive 127. Same is the case with the rest of the data type in the languages like Java and the C++. Now the good news about Python programming language is the range of the integer or the range of float, like I said, it's unlimited. Now when I say unlimited, it is subjective, or it is based on the available memory of the system. We generally refer to it as RAM. Okay, so based on the available memory, we could actually call it as a virtual memory. Some allocation of memory is allotted from the RAM to the execution of the programs, right? So based on the available the memory spaces in the form of RAM, accordingly, you can have the range for the integer and the float. So basically the range of numbers for integer and float are unlimited. But float is designed in such a manner that this will still have a greater range of numbers as compared to the integers. So the fact of the matter is, I want everybody to focus on this. Now when I say integer has unlimited range of numbers, the float has unlimited range of numbers, why unlimited? What is so good thing about the range being unlimited? For that you need to understand the data type of the languages like the Java and the C++. So in C++ also, we have the integer data type like the short, int, and then you have the long. For each of them, we have the storage capacity like 2 bytes, 4 bytes, 8 bytes. This will go on and on, right? So you have a reason to feel good about Python programming language, right? Over here, you don't have to learn anything about the data types of integers because there is just one. And you don't need to learn about the range being supported by the integer data type because there is none. It's unlimited, okay? But if I just go on to the explanation of this, the story will not be a complete one, okay? So this is the reason you need to understand this, just to strengthen your knowledge or basics, all right? Now the next up is, now we are done with the range of numbers, okay, which are supported by integer and float, which are basically, the unlimited, all right? Now let's move on to the next topic,